Hello everyone, it's your friendly neighborhood science teacher. Welcome back to another science lesson. Today we're going to be learning about how to use Newton's second law to solve problems related to force, mass, and acceleration. We already know that Newton's second law is F equals ma. This means force is equal to mass times acceleration. There we go. When working with this equation, there's a couple things to keep in mind. The first thing is that when we have two letters right next to each other, there is an invisible multiplication symbol between them. So when you are doing that equation, remember that you multiply mass and acceleration because of that invisible multiplication sign in between it. The second thing we need to talk about is what to do depending on which value is missing. So the way this equation works is that if we know two of those values, we can solve for the third. Let's say that we are solving for force. So we don't know what the force is. Let's say we are pushing a box that has a mass of 10 kilograms. And we know that it is accelerating at a rate of 5 meters per second squared. Because we have two values, we can solve for our missing one. So in this case, force is going to be 10 times 5, meaning force equals 50. And our unit for force is newtons. So we have 50 newtons if we're pushing a 10 kilogram box at 5 meters per second squared. So if we are missing F, our equation is F equals ma. We're going to put it off to the side as our equation key here. Now let's say we're missing acceleration. So we can do one of two things. We can still start with F equals ma as our base equation and plug in the two values that we don't know. So if we're missing acceleration, let's say force is 50 newtons, same as last time, equals 10 kilograms times a. Now a is our missing value. We don't know what acceleration is. So the way we need to fix this is by getting acceleration by itself. We need to get rid of this 10 kilograms. The way we do that is divide both sides by 10 kilograms. Then these two cancel out. So in order to find acceleration, we need to divide 50 by 10. If we divide 50 by 10, we should get 5 meters per second squared, because that's our unit for acceleration, equals a. However, there's another way to do this if you don't feel like writing it out that way. So we know that F equals ma is our base equation, but we can actually alter the equation for what we need. So if we do force divided by mass equals acceleration, then acceleration is by itself on one side of the equation anyway. Then you can plug in your values the same way you would in our normal base equation to figure it out. So in that case, it would be 50 newtons divided by, no, we had 10. Divided by 10 kilograms equals acceleration. And then you would solve it the same way. So in our answer key on this side, I'm going to say if missing acceleration, which is in meters per second squared. You're going to do force over mass equals acceleration. And now we have a new equation that you can use if that is the missing value. Now let's say we're missing mass. Let's try it first with our normal base equation, F equals ma. Our force is 50 newtons. We don't know m, and it is times 5 meters per second squared. Now we're missing m, and we want to have m by itself on one side of the equal sign. So in order to get rid of this 5 meters per second squared, we're going to divide by 5 on both sides of the equation. That means these two cancel out, and we're left with 50 divided by 5 equals m, which means that m equals 10 kilograms, because kilograms is our unit. If you just wanted to start with the equation that is set up for you, we need to have m by itself, so we can just divide by a on both sides. So force over acceleration equals mass. And you could plug in those numbers the same way. So if we have 50 newtons of force over 5 meters per second squared equals m, and you could solve it that way. So in our answer key, that would look like if missing mass, which is in kilograms, F over A equals m. Now we have 3 versions of the same equation for each situation we could have in a story problem. Let's try it again. I'm going to give you some of the values, and you can pause the video while you practice the problem on your own, and then unpause to see how I solve it. So again, our base equation is F equals ma. Let's say I want to know what force is applied if I have a 25 kilogram box that I am pushing at 10 meters per second squared. Go ahead and pause the video, figure out which equation you want to use, and then press play when you have solved it. All right, here's how you would do it. So force is our missing value, so we're going to use our regular base equation. Force equals 25 times 10, which means force equals 250 newtons. And that would be our answer. Let's try another one. I'm trying to find the mass of an object that has 20 newtons of force being applied to it, and it's accelerating at 2 meters per second squared. Go ahead and pause the video, figure out which equation you're going to use, and then press play when you're ready to see how it's solved. To solve this equation, I'm going to use this version of the equation because I am missing mass. So 20 divided by 2 is going to give me my mass in kilograms. 20 divided by 2 equals 10 kilograms. And that's my mass. Let's try one more together. I have an object that I pushed with 40 newtons of force, and its mass was 20 kilograms. Figure out which value is missing and which equation you have to use. Pause it, solve it on your own, and then press play to see the solution. Because I have my force and my mass, I know that I'm missing acceleration, which means I'm going to use this version of the equation. So I'm going to divide 40 by 20 to get my acceleration, which means my acceleration is 2 meters per second squared. And there you go. I hope this helped you work on solving those force equations. I will see you in the next one. Bye!